This lesson looks at some special properties in trigonometry that can be useful in various problems where you either need an exact value or you might want to take a bit of a shortcut. So, one particular property to know is the following. Sine squared plus cos squared is 1. But why is that? Well, remember the definitions with x, y, and r. So say you have your triangle with x, y, and r. Remember that sine is y over r, cosine is x over r, and r is the radius. And if you think back to the Pythagorean theorem, sine being y over r squared plus cos being x over r squared is equal to 1. Now, let's take a look at that. This means that y squared over r squared plus x squared over r squared is 1. Well, let's get rid of this denominator and multiply everything by r squared, which will eliminate our denominator and leave us with y squared plus x squared equals r squared. And what does that imply? Well, isn't that just the Pythagorean theorem for this here? X squared plus y squared equals r squared. Sure it is. So this can be useful, for example, if you know the sine, say you know that sine theta is 0.2. Well, then you could, instead of calculating cos of that angle, you could think that, well, 0.2 squared plus the cos of that angle squared will be 1, and therefore if I take 1, take away 0.2 squared, which is 0.96, and square root it, in the solving process, you'll find that cos theta is 0.98. Another special property that can actually be quite useful is knowing that the tangent is just the sine over the cosine. Let's go back to the definitions yet again. So the sine of theta was your y over r, your cos of theta is your x over your r, and your tan theta is your y over your x. Well, think about just taking your y over your r divided by your y over, or your x over r, and that would be y over r divided by x over r, which is the same as sine over cos. And what does that result to? Well, y over r times the reciprocal r over x will leave you with y over x, which is your tangent function. So this can be useful at times when you know, say, your sine and your cos and you want to find your tan. Or if you know the sine and the tan and you want to find the cos. So it depends on the circumstance, but this property can at times be useful. Another property to note is that of cofunctions. So let's take this triangle here, and you've got angles alpha and beta. Across from beta is B, side B. Across from alpha is side A, and you've got your side C, your hypotenuse. So let's consider sine of alpha. Well, sine of alpha is your opposite over your hypotenuse, which is A over C. Great. But you also know that cosine of beta will be A over C as well. It'll be adjacent over hypotenuse. So if we knew, so that's the same, cosine of beta, but we also know that alpha and beta are complementary. Why is that? Well, remember that a triangle adds up to 180. Here's 90. Those add up to 90. They're complementary. You complement them because they make 90. So, essentially, you know that the sine of alpha will be a cofunction to cosine because the cosine of beta, 90 minus alpha, will give you the same answer. So let's take an example. If you know that the sine of 30, and we know sine of 30, if you type it in your calculator, or if you remember that one, it's 0.5. Let's check if that's the same. So this is 0.5. Let's check if that's the same as cosine of 90 minus 30. Well, it should be, because if this is 30, then this is 60, and so the proportions should equal according to the picture. But let's try it out. So that'd be, is sine 30 equal to cosine of 60? Type in cosine 60, check it out, boom, they're both 0.5. So it's true. Also, tangent and cotangent are cofunctions as well. They work in the exact same way. So here's another example for you to check out. Finally, an incredibly special property in trigonometry that helps you find exact values. Anytime you see the word exact value in the heading of your question, you should be aware that you are likely going to be using special triangles to keep the values exact. Exact as opposed to decimal values. So rather than saying that sine of 30 was 0.5, you would say 1 over 2 or root 3 over something, that sort of thing. But before that, we need to know these special triangles. So let's create them. So one type of special triangle is formed by looking at a square. So if we look at a square and then cut it so that it has a triangle, we know that the sides were the same. So let's call them both 1 for the purposes of proportions. So what is the other side going to be, and what are the angles? Well, this is a 90-degree angle, and because it's the square, these were 90 and they were cut in half, these are now 45s. Okay, and what's the diagonal? Well, use the Pythagorean theorem. 1 squared plus 1 squared will be the diagonal squared. So that's 2 equals d squared. So d is equal to root 2. Now keep it exact, because this is going to help us with exact values. You'll see in a little bit some examples of that. So this forms the first special triangle, where you have 45, 45, 1, 1, root 2. The other special triangle is formed from an equilateral triangle cut in half. Again, cut in half, just like the square was. But what do we know about an equilateral triangle? Well, we know all sides are equal, so therefore all angles are equal. And since the angles add up to 180, if you split that equally amongst 3, you get 60 each. So you know that this is 60, that's 60, and that's 60. Okay, we've made a triangle here like this. So what's this top angle? Well, it's the complement of 60, which is 30. So that's our triangle there. Now, proportionally, say this was one side. We know that this side is the same length. So because we cut the bottom side in half, I'm going to call the longer part 2 and the half part 1, because 1 is half of 2. But then we don't know the height. So 1 squared plus height squared is 2 squared, giving us 1 plus h squared is 4, h squared is 3, h is root 3. Thus giving us the other special triangle of 60, 30, root 3, 2, 1. These triangles are incredibly important, and the reason why I showed you how to make them is because you can, if in doubt, make them on your own. Remember, the key is half a square or half an equilateral triangle, and you get the special proportions. These are going to be extremely useful. So let's find the exact values for the following. Let's redraw our special triangles. Can you remember them? Well, half the square was 1, 1, root 2, 45, 45, and 90. And half the equilateral triangle was 60, 30, and then 2, 1, and then root 3. Okay, so once we have those, now any time we have 60 or 30 or 45, in terms of angles, we know we are allowed to find exact values using these special triangles. So let's check out what the sign is of these key amounts. So the sign of 30, what's sign of 30? Well, you can look at the special triangle and you know the opposite over the hypotenuse is 1 over 2. So you know that sine of 30 is 1 over 2, and we actually just found that. Remember, sine of 30 was 0.5. Okay, cos of 30, well, that's adjacent over hypotenuse, and tan of 30 is going to be opposite over adjacent. Now remember, you don't want a root in the denominator, so make sure to simplify. What about sine of 45? Well, 45 is in this triangle, so the sign will be opposite over hypotenuse, root 2, so get rid of the root in the denominator, leaving you with root 2 over 2. The cosine is going to be the adjacent over the hypotenuse, which is as well going to be the same thing, root 2 over 2. And the tangent, which will be 1 over 1, which is equal to 1. Now find 60. 60 is going to be from this triangle. So you'll have root 3 over 2 for opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So the next super important thing to note is a reference angle. And the reference angle is the positive acute angle formed by the terminal side and the x-axis. Meaning, if we look back at our graph, notice how this angle here that's measured can get really big. Well, the reference angle is always the angle of the triangle. So wherever you are, that interior angle that's with the origin of the triangle with the x-axis. So here, it's approximately 45 degrees, even though it's at 326 or whatever. So here, the reference angle is normal, but as soon as you get here, notice here you'd have to go 180 minus 152. 180 minus 152 would be 28, meaning the reference angle here is 28. Or this one, that's 225. Well, in this case, you'd have to take 225 and subtract the 180, because that would be then 45. And here, notice if that's 318. Well, to get the reference angle, the angle in the triangle, you'd have to take, say, 360, take away 318. So as soon as you see the picture, it should make sense. So in this case, the reference angle is 42. And the reason why we need a reference angle is because if we're going to find the angle instead of just the value of the proportion, we're going to need the reference angle, the angle in the triangle. So what is the reference angle for 375? Well, 375 was approximately, actually it was bigger than 360, of course. So notice that 375, since it's bigger than 360, you're going to have to take away 360. So 375 minus 360 would be 15. What about 281? Well, where is 281? So you want to know, kind of have to have an idea of, well, that's 270, so that's probably 280 in here. So that's going to be 360. take away 281, which gives us 79. And what about negative 169? Well, you gotta unwind it. So negative 180's here, 160's in here. So that just tells us that this bit is 169, even though it's negative. That's 169. So how do we find this bit? Well, we just need to take 180 minus 169, and then we get 11. So the reference angle is always positive, and it's always the little angle there that's used. So every trig function of an angle, so say I was taking sine of negative 162 for this one. Well, that's going to be negative 0.31. Well, that's going to be the same as any other angle that leaves you with that reference angle, right? So as soon as the angle is the same terminal arm as a reference angle, the trig functions are plus or minus of each other, but the same values. So let's take a look at this example where we use reference angles to find exact values of the indicated trig functions. So let's say you have tan of 225. Well, we don't really know exactly what that's going to be. We don't know if it's going to be positive or negative. I mean, you can type in tan 225, but still you want to be sure that it's giving you the right value. So what quadrant is this in? Well, 225 is less than 270, so it's somewhere here, but it's bigger than 180. So all you need to do is take away 180. So you know that tan 225 is going to be plus or minus the same as tan of whatever 225 minus 180 is, which is tan 45. And we know that 45 is a special triangle, and also note that since you have exact values, you can't use a calculator to get the exact values. So you've got 45, 1 root 2 is your special triangle. What is tan 45 and what is the sine? Those are your two questions. Well, your sine is determined by the fact that it's a tangent in the tangent positive area. So it's going to be positive. So tan 225 is the same as positive tan 45. And tan 45 is the exact value of 1 over 1, which is 1. In this case, I lied. The calculator would give you tan 225 equal 1. However, you want to be careful of always depending on your calculator for these, because sometimes it may be a bit off or it may not be exact. So sine 150, well, where is that? Well, that's less than 180. So go 180 minus 150, which will be 30. So is it positive or negative though? CAST tells you that in this quadrant, sine is always positive. So sine of 150 will be equal to positive sine of 30. And from our triangle, 60, 30, root 3, 2, 1, we know that the sine is 1 over 2. So it's exactly 1 over 2. And finally, let's take a look at cos of 300. Where's 300? Well, it's bigger than 270, but less than 360. So let's go 360 minus 300. So sine of 300 is going to be similar to sine of 60. But is it going to be positive or negative? And again, in this case, we've chosen a positive one. Some of them say it was right here, then that would have been a negative. So just be careful of the sign. So that's still positive, sine 60 root 3 over 2. So in this particular case, it would be very difficult to find the exact value of cos 300 without knowing your special triangles.